So in this question, the density of a circular disk is given as rho, which is a function of p naught and x, where x is the distance from the center, and we need to find out the moment of inertia about an axis perpendicular to its plane and passing through its edge. Okay, so if this is the disk and this is the axis passing through the center, then we need to find out the moment of inertia of the disk about an axis which is perpendicular to the plane and passing through the edge. So this is the line about which we need to find out the moment of inertia of a disk, and there are the four options. So by the parallel axis theorem, uh, this is how we can find out this is the formula by which we can find out the moment of inertia, where IC is the moment of inertia about this central axis of the disk, which is perpendicular to its plane, and mr square is the moment of inertia, where m is the mass and rc is the distance from the center of the disk. And in this case, we're taking rc as a x, and so its differential form would be this, where del I is equals to dm x square plus dm r square. So integral di is equals to this, and on integrating the both functions we'll get p naught 2 pi r square by 5 plus p naught 2 pi r raised to power 5 by 3. Here it's a misprint, it's 5 not 2. So on adding these we'll get 16 p naught pi r square by 15, which is the answer about an axis which is perpendicular to the plane of the disk and passing through the edge. So correct option would be option B.